Friends, in today's lecture, we are going to learn how to create or how to generate surface-based rectangular periodic lattice structures. So let's design that. So we can give the file name as surface-based rectangular periodic lattice structures. Okay, and we can add the description as the design of surface-based rectangular periodic lattice structures using periodic lattice and rectangular cell maps and respective TPMS lattice unit cells. Okay, and our section name we can give it as like a TPMS. Also we can call it a surface based like a periodic lattices. So to design TPMS periodic lattices in nTopology, we already have like a periodic lattice, and within that periodic lattice, we have various input parameters, input geometrical parameters. We need to define them as per the requirement. So let's find out the periodic lattice. So we can go to the like here lattice tab, and then go to select the lattice tab. Here we can find the periodic lattice. So in periodic lattice, either we can use cylindrical or spherical or rectangular one. So let's select this periodic lattice. As I said that within periodic lattice, we need to define various input geometrical parameters. The first one is unit cell. So in today's lecture, our unit cell type is like surface based unit cells. So within topology, there is no any specific term of like surface based unit cells, but it is given as like TPMS unit cells with offset and without offset one. So we can select that one, and later on we can in this lecture we are going to use the cell map as a rectangular cell map, which is based on the Cartesian coordinate system, and based on the unit cell we need to define this unit cell parameter. So let's select them and define them one by one. So let's select the unit cell type. As here we can see this as like unit cells. Let's expand this. Yeah, as I said that graph unit cell means stud based unit cell. We already discussed this. In today's lecture, we are going to select the unit cell with offset. So in later on, we can create other unit cells as well. Unit cell, and we can create other lattice structures. So let's select the TPMS unit cell with offset. What do we observe here? We need to define it. This TPMS unit cell with offset means we need to define the like unit cell type. Let's observe. Let's check it. Yeah, here we have 6 type of surface based like TPMS unit cells. So for now we can select the gyroid one, and later on we can vary them as per our requirement. But this is the constraint of like TPM like nTopology software. Even though if you see the most of the TPMS unit cells, they are majorly like 6 to 7 only. If somebody wants to create any new like TPMS unit cell, they can use the trigonometric equations and they can generate the respective unit cell. So now for now we can select the gyroid one. Yeah, this is our gyroid unit cell, and yeah, it is within our bounding box like a cubic unit cell, and we can see the respective like like axis like UVW. Okay, now we can place this within the unit cell parameter. We have placed it. Now let's minimize this by pressing the space. Now we need to specify the like cell map. So let's minimize this as well. Yeah, what type of cell map today we are going to use? Like rectangular cell map. So where do we find that? We can find it from like here cell map we have now. Within the lattice tab we have the cell maps tab. So let's select this, and in today's lecture, as I said that we are going to use rectangular cell map. Let's select this. What do we observe here? Again, 3 parameters are there. We need to define the value. As I said, various volume you can select, but it will select the particular region within the Cartesian coordinate system. Okay, so let's select the volume. Now for selecting the volume, we can go to the create, and we can select select the primitive. From here we have the different types of volumes within the nTopology software. So we can select any one of them, for convenient and for simplicity purpose, today I'm going to teach you how to create the periodic surface based periodic unit cell within the box. So this is our box. So here by default we have the length, width, height as a 10 mm, 10 mm, 10 mm. If somebody wants to vary it, they can vary by changing the values of them. So I can go with this only. So let me place it here within the value. Okay, yeah, we have placed it now. Now, now, now let's define the cell size. Cell size means now our entire cell map size is 10 mm, 10 mm, 10 mm value. Now we need to define the unit cell size. Like it must be less than the cell map size. So unit cell size, it is up to you. You can do 10 mm or 5 mm or 2 mm. So for now, for simplicity, I'm going to give the 2 mm and 2 mm, 2 mm cubic unit cell. If somebody wants to change the other unit cells, like suppose 4 mm, suppose like 3 mm, yeah, this is how they can change it. It is up to you. So today for simplicity I'm going to give the like a cubic unit cell. What do we observe? We have generated the Cartesian coordinate system based rectangular cell map. Okay, this is like within the cubical shape only. If somebody have the like conical shape or something other else, they can generate the cell map with respect to that only. So for now I have given the our unit cell size as a cubic only. And if somebody wants to create the frame, they can create. It is up to you, it is optional. So for this I'm not going to create any frames. I'm going with that only. Let's place this rectangular cell map within the cell map itself. Okay, now final, as I said that once we have selected the respective unit cell, the parameter unit cell parameter change its name with respect to the unit cell. So as we use the gyroid unit cell, it has a respective mid surface thickness offset. Okay, we need to mention this parameter. So let's select any random values like up to 0.2 m5 as I use regularly. 0.25, let's 0.25 mm. Let's wait and see. Yeah, we have generated our uh, like uh, gyroid unit cell. So what do we observe? We have the like a cubical periodic lattice, and our unit cells are perfectly repeated now, but it is fully densed. I think it has a higher relative density and a lower porosity. So I hope if somebody wants to check it, if I give the point one, let's see what is going to happen. We can reduce its porosity. Okay, yes, now see how beautiful it is. Now we can clearly see its structure and its behavior. Yeah, okay, this is how one can generate the periodic rectangular lattice for surface based unit cells. So if somebody wants to change other unit cell, like as I said, total we have 6 unit cells. Okay, so let's select like diamond unit cell and see what is going to happen. Wow, how beautiful it is, isn't it? So this is our diamond unit cell, and it is also it has a higher density. So if somebody wants to decrease the its density, they can simply change this parameter as 0.5. And let's see, like yeah, so mid surface is still having this much only. Hope it is not changed that much. Why? If somebody wants to use like new vs, they can also use it. Why it is like this? 1 mm. Wow, okay, it means I need to go slow small. Yeah, this is our Nevius unit cell. Okay, so if somebody wants to see its cross section, they can simply see its cross section. Yeah, this is our original unit cell and lattice structure. Okay, of the Nevius, and we can just change its. This is how it exactly looks. How beautiful it is. Okay, so this is how one can generate the various lattice structure. As I said, so in today's lecture, what do we learn? We learned that we have how to create the periodic lattice within the rectangular cell map of surface-based lattices. So for that, we have selected the periodic lattice from the lattice tab, and later on we have defined various unit cells and cell map as a rectangular cell map, and we have given the unit cell parameter as a mid surface offset. So that's it for today. So I hope you understand. So thank you.